Hello, what is up, ladies and gentlemen? My name is Mike and welcome to Radical Academy. In this video, we'll be learning about balancing of the chemical equation or chemical reaction. Now, this is a basic fundamentals of chemistry that we're supposed to understand the meaning of what is a chemical equation, or rather what is the meaning of a chemical reaction. Now, with that said, our main focus in this video is going to be mainly on how we can do an electronic configuration of an element or just an atom, and also how we can actually balance the equation and do examples about electronic configuration and balance an actual example about a chemical equation. So I want to first of all ensure that we do understand what is the meaning of an electronic configuration. Okay, knowing that an atom has a proton, electrons, and neutrons. Okay, so the proton and the neutrons, they are found in the nucleus. They are found in the nucleus. And then the electrons are found in the shell. Okay, in the shell. So when it comes to electronic configuration, we mean we are only going to consider an electron which is found in the shell. But of course, I want you also to understand that an atom which is not involved in a chemical reaction is defined to be electrically neutral, or it is neutral, meaning that the number of electrons equals to the number of protons. Okay, so the number of electrons equals to the number of electrons. That is for an atom that has not taken part in a chemical reaction. So there comes now, when you talk about electronic configuration, we are dealing with electrons. Indirectly, we are also dealing with protons. For instance, when I take sodium, which has the mass number of 23 and 11 protons. Okay. This means that this 11 is also equal to electrons. So when I'm doing an electronic configuration, I'll be using the proton number, which is also referred to as atomic number. Okay. Now, if we want to understand an electronic configuration, then we need to understand how we can do that. So if you have got sodium, then it simply means that I can now divide this number of protons into some kind of fractions or ratios, okay? Which means that whenever you're doing an electronic configuration, the first number is 2, followed by 8. So when you look at 2 and 8, when you add together, it will give you 10. But now, what number remains so that you get 11? It's just 1. So that means I've configured sodium. Okay. Now, these numbers that we have done, that you have configured, they give us some information that is very cardinal about that element. Okay. So I say sodium, it simply means it has 1, 2, 3. It has 3 shells. Okay, so meaning that the number of shells equals to the period of that element. Meaning that when I go on the periodic table, I will discover that sodium is in period 3. Since when I draw an atom of sodium, the structure of sodium, I'm going to have 3 shells. So meaning in the first shell, I'll just have 2 electrons. And then in the second shell, I'm going to have 8. And then in the last shell, so this is second, then third shell, I'll just have 1 electron. Okay, so this is the meaning of electron configuration. So you can get other elements and then apply the same concept. Okay, now after that, the number of shells, those circles, they give us the information that sodium belongs to the period 3, belongs to period 3 on the periodic table. And then now the last number, okay, this last number gives us information about the group number to which sodium belongs. So now, meaning that the last number there will tell us that sodium belongs to group 1 on the periodic table, and then the same last number also tells us to say sodium has a valence of 1. Okay, sodium has a valence of 1. Okay, which is going to be very cardinal when it comes to the balancing of the chemical equation. Understanding the valences of each and every single element becomes very cardinal, because we use the valence number to determine the number of atoms that will be shared when 2 elements combine together to form compounds. Okay, we shall see that in just in a minute. Okay, now after we understand electronic configuration, when you also, for instance, about calcium, when you go on the periodic table, you discover that calcium has a mass number of 40, and then the chemical symbol is C, capital C, small a, and then the proton number 20. So for us to configure this 20, then we'll just do the same thing that we did on sodium. So you always start with 2, and then followed by 8. So if the number is bigger, just continue with the 8, 8. Okay. Now, when you reach at maybe the second 8, try to add the 2 and see how many more you are remaining with, so that you can know if you are going to terminate or not. So 2 plus 8 is 10. 10 plus 8, it is 18. So now, what number remains so that when you add together, we get 20? So on 18, only 2 remains. Okay, so the number that remains is 2 as the last number. Okay. Now you have done the electronic configuration for calcium. So you can keep on practicing and see if you get to understand what we mean by that. Okay, so now you can see that under calcium we have this is the first shell, second shell, and then third shell, and then fourth shell. So when you configure calcium, it is forming 4 shells, meaning that calcium is now, so calcium is in period 4, and then the last number after you have configured calcium tells you that the group number to which calcium belongs is 2, and then also the valence is 2. Okay, so the group number equals to the valence number. So make sure that that information is understood, because it's going to become very cardinal when you come to the other topic, which you are calling bonding, chemical bonding. So I want to emphasize that if you want to understand this, make sure that you keep on practicing and see how good you are going to get at that electronic configuration. Then you'll be able to see that chemistry is very simple and straightforward. Okay, now having understood those key concepts, now we can go, we can move on the concept of understanding how we can make, how we can now do, how to balance a chemical equation. So now for us to balance a chemical equation, there is some quick concept that we need to understand. Okay. Something that we need to understand. Now I'll give a, if you just really want to understand how to balance a chemical equation, it's all about trying to understand the electronic configuration of that particular element, and then be able to understand what is involved in a chemical reaction. Okay, so balancing a chemical reaction is very simple. All we are doing is ensuring that the number of atoms on the product, on the reactant side, should be equal to the number of reactants of the same thing that appeared in the reactant should be the same as those that are reappearing in the product side. So what we mean by that, I'll give, first of all, before we get into the actual balancing, I'll give you the actual idea of what I'm talking about. Let's take, for instance, the simplest chemical equation, which is the formation of water. Okay, so let's say hydrogen plus oxygen equals to H2O. Okay, now this is the simplest chemical equation, but very important equation. Hydrogen plus oxygen equals to water. If you want to understand that, then I must ask myself, where is the 2 coming from? Okay, and then what about this 2? What about that 2? Then this now starts to get now more exciting. Okay, because when you're writing gases such as hydrogen, oxygen, nitrogen, and other essential gases, we write them with the mindset of saying that these are called diatomic atoms. Okay, they are diatomic, meaning that they exist as 2 atoms of one molecule. Okay, the number in front there is refers to molecules. The number down here refers to atoms. So if they ask you how many atoms are in the water molecule, so there is only 1 oxygen, there is only 1 there, and 2. So altogether, the number of atoms in the water molecule is just 3 atoms. are the ones that are making up the water molecule. Okay. Now, the other key concept is about the valence. Okay. The valence. Why the valence? Because if I want to say sodium, if I want to say calcium plus, let's say calcium plus chlorine equals to calcium chloride. Okay. Now, when your chlorine reacts with an element, it is no longer a chlorine atom, but it becomes a chloride. Okay, a chloride. So this is going to be calcium, then Cl2 punch pipe. Number 2, yafuma kwisa. 2, it is the valence of calcium. Okay, 2 is the valence of calcium. Please understand that. So when two atoms are reacting, okay, they kind of exchange their valences, okay. The valences swaps, okay. They exchange their valence. So this calcium, which we have configured right over here, it has a valence of 2, and chlorine has a valence of 1. So now when they form calcium chloride, this is going to, the 2 for calcium will go to chlorine, and then the 1 for chlorine will come to calcium. So the chlorine is going to have 2 atoms, and then calcium just 1 atom. So if we want to understand how a chemical reaction is done, balancing a chemical reaction is done, make sure we understand how we can configure each and every single element that is taking part in a chemical reaction. So please, my emphasis is understand electronic configuration. Once you understand electronic configuration, then it becomes so simple to balance a chemical reaction. Okay, so now in conclusion, let's see now how we can balance a chemical equation. So I'll get the simple equation, but of course I'll also release the video, some other videos that will be talking about other complex equation and balancing of those complex equations.